Hello and welcome students. This is a lecture on planes, and in the previous lecture of planes we had done few of the very important topics like we had done angle between two planes we did. Then we also did the angle between a line and a plane. Then we did perpendicular distance. We did distance of a point from plane. So these are the chapters, these are the topics, I'm sorry, not the chapters. These are some topics which we did in the previous lecture, previous class. Now in today's class, what we are going to do, you see the heading here. We are going to work on coplanarity of two lines. So see students, when do we say that two lines are coplanar? The two lines are coplanar when the two lines are lying in the same plane. The two lines are said to be coplanar when they are lying in the same plane. Okay. So here, say, I have a plane here. Okay. So this is a plane. This plane is, say, alpha plane. Now, in this plane, I have two lines, and those two lines are here. Okay. This is one line. Yeah, this line, see, the plane is an infinite plane. You cannot contain a plane like this. But then for the sake of understanding, we need to do it this way. But then you understand a plane is an infinite plane. And here you have another line. So what happens, the plane is an infinite plane. There is no boundary as such for a plane. What you need to understand is there is no boundary as such. So this is plane, yes, this is plane. But you cannot put a boundary to the plane. This plane will go like this till infinity. Yes, this is how it is. This is how it is. So if the plane is an infinite plane, remember that these lines are also infinite lines, both the ends. They are endless lines. But then for the sake of understanding, I do it this way. So see, here I have got line L1 and this is line L2. Okay, I write the equation of line L1. So I write here, line L1 has equation. L1 has equation, as you all know, R bar is equal to A1 bar plus lambda B1 bar. Okay, so what is A1 bar? Basically what is happening is on line L1, there is one point, and that point is, say, on line L1, there is a point which is A1. Okay. Now this point A1, when you join with origin, where is origin? See, if you are discussing this all in space, so there has to be one point, somewhere origin. So when you join this O with A1, what you are getting is the vector A1 bar, which is the position vector of point A. This is A1 bar. But my dear students, remember, we are not going to show the origin. We are not going to show these position vectors. It is just understood that these all are there. Okay, so A1, point A1, which is on line L1. And what is B1 bar? See, B1 bar is a vector which is parallel to line L1. This is B1 bar. Okay, this is B1 bar of vector parallel to line L1. Yes, this is vector B1 bar. Fine. Now I have line L2. What is L2? L2 has equation R bar is equal to A2 bar plus mu B2 bar. Now you know what is A2 bar. Once again, same thing, This is point, there is a point here. There is a point here which is A2 on line L2. its position vector with respect to O will be A2 bar. And then you have a vector which is this one. You see this? This is B2 bar vector which is parallel to B2 bar, you know, is parallel to B2 bar is parallel to line L2. Okay? Yes. Now, so here you have the whole picture. Now tell me, students, if I join, let me join the point A1 with point A2. So when I join point A1 with point A2, what do I get? I get a vector which is A1, A2 bar. You see this? This vector is A1, A2 bar. Okay. Now tell me, if I make a statement that A1, A2 bar is a vector which is lying in plane alpha, is the statement true? Yes, the statement is true. Why? Because see, L1 is in the plane, L2 is in the plane. So if L1 and L2, these are two lines in the plane alpha. So point A has to be in the plane. See, point A is in the plane, A2, point A1 is in the plane, point A2 is also in the plane. Hence, the vector A1, A2 bar, this vector is also in the plane. Okay. So now see, students, the two lines are in the plane. Okay, two lines are in the plane. So since the two lines are in the plane, this two vectors B1 bar and B2 bar are also in the plane because they are nothing but parallel to the two lines. So see here, I will write here. Okay, let lines L1 and L2 be coplanar lines. Let lines L1 and L2 be coplanar lines. Therefore, we can say that vector A1, A2 bar also lies in the same plane. Okay. So students, now I go ahead and see what do I write. I'll write here. Therefore, we can say that, A1, A2 bar, B bar, B1 bar and B2 bar are coplanar vectors. See? Why? Because see, B1 bar and B2 bar, they are already coplanar. Now this A1, A2 bar is also lying in the same plane. Yes. So these three vectors, B1, A1, A2 bar, B1 bar, B2 bar, they are coplanar vectors. And you know, students, if three vectors are coplanar, what will happen? Their scalar triple product is zero. So I will say, therefore, we can write what their box product is zero. So A1, A2 bar, B1 bar, B2 bar is equal to 0. Okay, that is A1 A2 bar dot B1 bar cross B2 bar is equal to 0. Okay, see, this is 1, this is 2, they are one and the same thing. So what is this? Remember, students, if this happens, you can call it as condition for coplanarity of two lines. This is known as condition for coplanarity of two lines. This is condition for coplanarity of two lines. So what I understand here is, suppose I'm given two lines, okay? If I'm given these two lines, I'm given these two lines, and I'm asked to check whether these two lines are coplanar. That is, they are lying in one plane. What will I do? For these two lines, I'll find out this thing. And if I'm getting this equal to 0, that is, I'll find out the box product. If I'm getting the box product 0, then I will say that these two lines are coplanar. Okay. Yeah, as you know, students, A1, A2 bar is nothing but A2 bar minus A1 bar. Okay. So I can take this discussion ahead by stating, suppose you have coordinates of point, suppose you have coordinates of point A as x1, y1, z1, okay, and coordinates of point B as x2, y2, z2. Say B1 bar, this vector B1 bar is, say, say A1 I cap, B1 J cap. See, this B1 is again coming here. So do not worry. C1 K cap. Okay, so this is vector B1 bar, this white vector, right? And B2 bar is, say, B2 bar is this white vector is suppose A2 I cap plus B2 J cap plus C2 K cap. See, I could have taken alpha 1, beta 1, gamma 1, but then I did not want to do it. It is just, you know, just for the sake of understanding. Fine. So if you have this way, then what will the condition be? See here. You know, students, then this equation number 1, which is the box product, see, this will be, first of all, let me write, it will be A2 minus A1, A2 bar minus A1 bar, box of, then B1 bar, B2 bar equal to 0. That is, now you know what is A2 bar minus A1 bar. If you have A1, see A1 bar, how will A1 bar be? It is needless to say that A1 bar will be A1 bar. Okay, let me write here only. See, this is point A1. Okay, so small A1 bar will be x1 I cap plus y1 j cap plus z1 k cap, and A2 bar will be x2 I cap plus y2 j cap, okay, plus z2 k cap plus z2 k cap. So what will be A2 bar minus A1 bar? It will be x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, right? So here this will become, what will it become? It will become now, it will become here x2 minus x1, y2 minus y1, z2 minus z1. You know, we are writing the box product. You know, box product is always written in determinant. And for B1, what will write A1, B1, C1, because that was B1 bar. And B2 bar is A2, B2, C2 equals to 0. This is the condition. This is the condition. If you are writing in Cartesian form, even this can be the condition. Okay? Condition for coplanarity. Condition coplanarity of two lines. There is one very interesting fact, interesting thing that we need to be knowing. And that is, students, suppose I am given these two lines, okay, and they say find whether these two lines are coplanar. What will I do? See, I will go by the condition of coplanarity. I will check whether this box product is equal to 0. If I see that this box product is 0, that is LHS becomes equal to RHS, then I will say, yes, these two lines are coplanar. These two lines are coplanar. I will say that these two lines are in one plane. Okay, that's good. But suppose the next part here, someone says, these two lines are coplanar. Find the equation of that plane. You understand? First, they say, check whether the lines are coplanar. You will check by this condition. Then the next step, they say, find the equation of that plane in which these two lines lie. Find the equation of the plane in which these two lines lie. What we will do? Very simple. You know, students, as you all know, for getting the equation of any plane, what is required? You need one point on the plane and a vector perpendicular to the plane. So do I know a point on the plane? Obviously, see, if the two lines are on the plane, so this point and this point, they are on the plane. So I will need any one point. I will need any one point. Okay. Yes. I will need any one point. So say I will take this point A1 on the plane. And now I need a vector perpendicular to the plane. So what I will do? I will find out B1 bar cross B2 bar or B2 bar cross B1 bar. If I'm getting B1 bar cross B2 bar, what will happen? See here. I will show it to you. This is vector B1 bar. Yes, I shifted here. I got this as B1 bar. Now I'll find out vector B2 bar cross B1 bar. And what is that going to be? You all know B2 bar cross B1 bar is a vector this way. You see this? And this vector is what? It is perpendicular to both. It is perpendicular to both. And since it is perpendicular to both, it is automatically perpendicular to the plane. You got that? B2 bar cross B1 bar. And what if I find B1 bar cross B2 bar? That is also okay. You know why? Because then that vector is going to be perpendicular to the plane and it's going to be this way. See, this is also perpendicular to the plane. This is B1 bar cross B2 bar. So both are okay. You can find B1 bar cross B2 bar or you can find B2 bar cross B1 bar. This is your normal vector. We have already done this thing so many times. Okay, so let's begin. So what I will write? I will write here the equation of this plane. I'll write here. I'll write the equation of plane where L1 and L2 lie, L1 and L2 lie is given as follows. Is given as follows. See what you will do. You have a variable point R. Yes. So you will write R bar dot R bar dot B1 bar cross B2 bar, R bar dot N bar is equal to A bar dot N bar. So R bar dot B1 bar cross B2 bar is equal to A1 bar dot B1 bar cross B2 bar. How is this coming? If you have any such doubt in your mind, if you have a doubt, how is this coming? It's very simple here. See, you have a variable point here, R, yes. You will join this A1 with R, yes. So the vector is A1 R bar, yes. This is the vector A1 R bar, yes. And what is the normal vector? What was the normal vector? The normal vector was this. B1 bar cross B2 bar, yes. So you will say that A1 R bar dot B1 bar cross B2 bar is 0. Yes, sir. Yes, sir. So here it is, you will say A1 R bar dot B1 bar cross B2 bar is equal to 0. That is R bar minus A1 bar dot B1 bar cross B2 bar is equal to 0. In case if you forget, you can do this whole process. Now, this dot you will distribute over difference. So you got R bar dot B1 bar cross B2 bar minus A1 bar dot B1 bar cross B2 bar, that is equal to A1 bar dot A1 bar dot. You understand? It's like this. A1 bar dot B1 bar cross B2 bar. This is it. I have written it here. Okay. So students, now following this, you can let us solve some problems on this, and that will be the end of the topic plane. So students, here we have a question which is based on coplanar condition of coplanarity of two lines. Okay. And remember, this is one of the most important questions that you can have for based on planes. So let us see what this question is. See what the question says. It says that show that lines, see you got two lines here, show that the lines, this line and the other line, show that these two lines are coplanar. Okay, so how will you do it? We will do that. And also find the equation of the plane determined by them. Okay, so if they are coplanar, actually, when the question is show that, always the lines are coplanar. And then after that, what I have to do, I have to get the equation of the plane which is determined by those two lines. That is equation of the plane on which those two lines are lying. Okay, so how will I begin? See here. This is the first line. So I will write, let the lines be L1 and L2, okay. Then I will write, let A1 and A2 be the, see, these questions, if you are solving in MCQ based, JEE or, yeah, please, this question can come in JEE and also in respective entrance exams that we start for the stage. So see, you will write, if you're writing for MCQ, then you don't have to write all this. But then if this is a subjective, if this question comes in your board exam, which is it is very likely that this question can come in board exam. And if it is coming in board exam, it will come for 4 marks. So you are writing, let A1 and A2 be the points with the points on lines L1 and L1 and L2 respectively, okay. So what am I given? Therefore, A1 bar, my dear students, A1 bar is, this is A1 bar. A1 bar, and this is A2 bar. So I shall find out, I shall write A1 bar. So A1 bar is 2j cap minus 3k cap. And what is A2 bar? And A2 bar is 2i cap plus 6j cap plus 3k cap. Okay, this is A2 bar. I got A1 bar and A2 bar. Then I will write let B1 bar and B2 bar be two vectors parallel to. I'll write here let B1 bar and B2 bar, B1 bar and B2 bar be two vectors parallel to lines L1 and L2 respectively. Okay, that is B1 bar is parallel to L1 and B2 bar is parallel to L2. So I got it. So what is B1 bar, my dear students? So here B1 bar is, therefore B1 bar is, this is B1 bar, I cap plus 2j cap plus 3k cap, I cap plus 2j cap plus 3k cap, and B2 bar is 2i cap plus 3j cap plus 4k cap. Okay. And you know, in order to have the two lines coplanar, what should happen? What should happen? So here I write the two lines are, okay, I will write in this patch. So distinct background I'm making. Okay, so here I will write the two lines after this. Okay, after this I'm writing here. So I will write here the two lines, the lines are coplanar. I'm sorry. Coplanar if A1, A2 bar, box product of A1, A2 bar, B1 bar, B2 bar is equal to 0. That is, you know, A1, A2 bar. A1, A2 bar is what? A2 bar minus A1 bar. What is A2 bar minus A1 bar? No, students, A2 bar minus, okay. That is, you can write here, that is A2 bar minus A1 bar, B1 bar, B2 bar is 0. That is, now you know that this box product, basically the left hand side is nothing but the determinant. So what is A2 bar minus A1 bar? This is A2 bar. So 2i cap minus 0i cap, that is 2, right? And then 6j cap minus 2j cap, 4j cap. So 4, then 3k cap minus of minus, so this will become 6k cap. I will suggest that you find A2 bar minus A1 bar. Okay, and then you have B1 bar. What is B1 bar? 1, 2, 3, and B2 bar. What is B2 bar? B2 bar is 2, 3, 4. That is, this is equal to 0. So what I'll do? Now I'll go for LHS. I will take LHS. So here I write, what is LHS? 2, 4, 6, 1, 2, 3, 2, 3, 4. So my LHS is, I will write here LHS, and so basically what is going to happen, students? I need to prove that LHS is equal to RHS. This is what I need to prove. So what do I have? I have 2, 4, 6. I have 2, 4, 6, 1, 2, 3. And here I have 2, 3, 4, right? 2, 3, 4. I use the property of determinant. You see that in the first row, you have 2 common. So that 2 will go out? Yes. So when 2 goes out, what do you have? You have 1, 2, 3. From the first row, I'm taking 2 out. And again, 1, 2, 3, and 2, 3, 4. So what do you got? You got the first row and the second row are identical, so you write 2 into 0. You know, if any two rows or any two columns are identical, the value of the determinant is 0. So this is 0, which is equal to RHS. So I will write, okay, here you can write, since you can write here, since R1 and R2 are identical. They are identical. Okay. Now, students, after this, what is the next step? The next step, you know, I shall write here. Sorry. The next step is I write since the condition for coplanarity of two lines. This all you need to write only for board exam. If the answer is a subjective answer, essay type answer, then or else it's not required. Since the condition for coplanarity of two lines is satisfied, see why? Because here you know LHS equals to RHS is satisfied. Therefore, the two lines are therefore the two lines, the two given lines, in fact, the two given lines are coplanar. What's the next part of the question? We need to find the equation of that plane. Okay. So for finding the equation of the plane, what I'll do, I will take one point and do it. So here I will write the equation of the plane. The equation of plane is given as, see here, you know, it's A1R, where R is the variable point, A1R bar, okay, A1R bar dot B1 bar cross B2 bar is equal to 0. For that is R bar minus A bar. So you have R bar minus A1 bar dot B1 bar cross B2 bar is 0. That is equal to, you got R bar dot B1 bar cross B2 bar equals to A1 bar dot B1 bar cross B2 bar. What you need to do here is, you know, that's it. You just have to find this. Let me write this as 1. I need to find B1 bar cross B2 bar first. Okay. So here I'll go for B1 bar cross B2 bar. Okay, students, it also depends, you know, if they are asking you the Cartesian equation of the plane or the vector equation of the plane. If they're asking you the vector equation, then you will go by what is required. And if they're asking you Cartesian equation, then you know, then you can use the scalar triple product. So basically, what is this? See, say they're asking me the Cartesian equation. So you know, this is R bar, B1 bar, B2 bar here. For that, box of this, and here you have A1 bar, B1 bar, B2 bar. If they are asking you the Cartesian equation, this is going to get you the Cartesian equation. Okay, now what, you know, these all you will just write. So for, you know, what is R bar is X, Y, Z. B1 bar you already know. B1 bar you already know. This is 1, 2, 3 and 2, 3, 4. You have here 1, 2, 3, 2, 3, 4. Okay, this is the determinant for the, and this side what you will have A1 bar. What is A1 bar? A1 bar is 0, 2 minus 3, 0, 2, 0, 2 minus 3. B1 bar is 1, 2, 3. B2 bar is 2, 3, 4. Okay, students. So you solve this and you will get the Cartesian equation of the plane. Had they asked us the vector equation, in that case, we'll not go by this. Instead, we'll find this B1 bar cross B2 bar, right, with R bar dot, and here, get the dot product of these. So I hope in the question, had they said anything? Vector, no, nothing. Find the equation, so it can be anyway. So here I write, so students, so in the next step, I get here x into x into 8 minus 9, 8 minus 9 minus y into, we are expanding the determinant, minus y into 4 minus 6, 4 minus 6 plus z into 3 minus 4, 3 minus 4 equals to 0 into anything is 0, so no need to write. Minus 2 into here you have 4 minus 6. Minus 2 into 4 minus 6, okay? And minus 3 into 3 minus 4. Minus 3 into 3 minus 4. So you get here minus x. This is plus 2y minus z is equal to, this is minus 2, so 4. And this is minus 1 plus 3. So you got here minus x plus 2y minus z minus 7 is 0. That is x minus 2y plus z plus 7 equals to 0. This is the equation of plane. This is, I write here, this is the required equation of plane. So students, this completes our plane completely. Thank you. I hope you all have understood everything. You can watch the video again and again. Thank you. God bless you. Bye.